All right, so we're skipping section 4.2 for a little bit, and we're going to go to right triangle trig, which is section 3. And if you're in physics, I understand you've already been doing some of this stuff. And any of you who had geometry learned about the first part of trigonometry. So we can represent trig functions in a lot of different ways. And so we're going to start by looking at trig functions from a right triangle perspective. If you remember from your geometry days, we had a little, what is this, an acronym? So, TOA. So if you remember that at all, it was supposed to help us remember how to write the sine function, the cosine function, and the tangent function. So before we get into that, using the lengths of the three sides in a right triangle, so the two legs and the hypotenuse, you can form, there are actually 6 trig ratios that define the 6 trigonometric functions of an acute angle theta. So the 6 trig functions are listed as sine, cosine, tangent, so you know those. But then the reciprocals of those are cosecant, secant, and cotangent. All right, so the good news is these are just reciprocals. So if you know sine, cosine, tangent, by default, you know the other 3. All right, now, if this is theta, then this would be the leg or the side opposite theta, and this would be the leg or the side adjacent. Adjacent means next to theta. The hypotenuse is always across from 90 degrees, so it's never considered adjacent or opposite of the angle we're looking at. And theta will only ever be one of the 2 acute angles in the triangle. It will never be the 90-degree angle here. All right, so sine of theta is equal to the opposite leg over the hypotenuse. So we had so to help you remember that, right? That's the so part. Cosine, because it's ca, is equal to the adjacent over the hypotenuse. Adjacent leg over hypotenuse. And tangent is the ratio of the opposite side over the adjacent side. So that's the so, ca, toa piece. It just helps you remember what those 3 ratios are. And if you know sine, cosine, tangent, and you know which reciprocal goes with which, then it's just a matter of flipping. So cosecant is the reciprocal of sine. So it is hypotenuse over opposite. Secant is the reciprocal of cosine. So that's hypotenuse over adjacent. Cotangent would then be adjacent over opposite. All right, so I don't have those memorized. That'd be like cho, sha, cow or something. But if you can remember SOHCAHTOA and then flip those, you're in good shape. All right, so use the triangle to find the exact values, meaning no decimals, of the 6 trigonometric functions of theta. So what we need to do here is first find a missing side if we have it. So we have legs 3, 4, and you might remember your Pythagorean triples. This third side is 5. If you don't remember that, or if you're not sure, you just do 3 squared plus 4 squared equals the hypotenuse squared, and you solve for that. All right, so we get the missing side. And so when you're writing this, you have to make sure, I want to add a note up here. Always write your sine or cosine or tangent of theta. You have to have the angle. Oh, can't write today. You have to have the angle. It's not just sin, cos, tan. It's sine of theta, cosine of theta, tangent of theta. It's got to be of an angle. Sine, cosine, and tangent, they're kind of like operations, just like natural log and all the stuff we've been doing. Okay, so to begin, I'm going to write sine theta equals, and 4 is the opposite leg of theta, 3 is the adjacent leg, and 5 is the hypotenuse. So sine of theta is 4 over 5. Cosine of theta is 3 over 5. And tangent theta is 4 over 3. Now the reciprocals, you just have to remember which goes with which. So cosecant is the reciprocal of sine, so it's 5 over 4. Secant of theta is 5 over 3. And cotangent of theta is 3 over 4. So those are my 6 trig functions. You do have to write the trig function part. It's not good enough just to list out 4/5, 3/5, 4/3, because that doesn't tell me which trig function goes with which number. We have to reduce fractions and simplify radicals. Now, this is not a triple that I'm familiar with off of the top of my head, so I need to use Pythagorean theorem, and this time it's to find this leg. So let's just call this leg A. So a squared plus 2 squared equals 4 squared. A squared equals 16 minus 4. So a equals square root of 12, which is 2 radical 3. No plus or minus because we're talking about side lengths here. Okay, now you can start doing sine, cosine, and tangent, but let's do the first one. If I don't do anything to this triangle and I just start it on sine, I get sine is 2 over 4. Well, that reduces, right? 1/2. And cosine is 2 radical 3 over 4. Again, that reduces. Radical 3 over 2. So actually what we should do is use a similar triangle. Because all of these are going to reduce and we have to reduce them, you can use a similar triangle. Sometimes I say in my head, like, reduce the triangle, basically. Basically, if the 3 sides have a common factor like this, or if the 2 sides you're given have a common factor, you can divide it out. You can say, actually, let's just divide every side by 2. So the hypotenuse is 2, this leg is 1. This 2 radical 3 divided by 2 would just be radical 3, and theta is in the same position. And then it's so much easier because you don't have to get the answer and then reduce. You just go from the reduced state right to begin with. So sine of theta was 1/2. Cosine of theta was radical 3 over 2. Tangent of theta, let's use this triangle then, is 1 over radical 3. Now, you do need to rationalize. Now, in calculus, they don't really care if we leave our answers like this. But in pre-calculus, they do want us to rationalize our denominators. So multiply by radical 3 over radical 3. Just get used to doing that. Then you get radical 3 over 3. I like to have the unrationalized version on my paper, and I'll show you why in a second. When it comes down to the reciprocals, now it's a matter of flipping everything. So cosecant of theta is the reciprocal of 1/2, which is 2. Secant of theta, when I flip this, I'm going to get 2 over radical 3, which has to get rationalized. 2 radical 3 over 3. Cotangent, now here's where I like to have the original. Go off of this original before you rationalized and flip that so it's simplified right away. Otherwise, the long way is to say, okay, it's 3 over radical 3, and then I got to rationalize, and then I get this, and then I get that. You get to the same answer, but instead of doing it in one step, it took me like 2 or 3. All right, draw a right triangle based on the value of the trig function. Label all 3 sides and mark in ... I don't know. We're going to label all 3 sides, and I think what I meant to write there was, well, we want to find the remaining 5 trig functions. I'll have to check to see if I fixed that for your notes packet. Okay, so how do we draw this? Well, we know that sine is opposite over hypotenuse, so let's start there. Give yourself any right triangle. It really does not matter if it's to scale or not. I always draw the same triangle. Put theta anywhere you want. Let's say we put theta up here this time just to change things around. Wherever you put theta, you just need to put your opposite leg so that it's actually opposite theta. The hypotenuse has to be 13. And again, you might know your triples, or if not, Pythagorean theorem, 5 squared plus b squared equals 13 squared, and go from there. But this is a 5, 12, 13 triangle. So draw the right triangle, check. Label all three sides, check. And now based on where this theta is, we're going to find the remaining 5 trig functions. So we already have sine. Let's go with cosine theta. It's 12 over 13. Tangent theta, 5 over 12. Reciprocal of sine is cosecant theta, 13 over 5. Secant theta, 13 over 12. And cotangent theta, 12 over 5. All right, tangent of theta is 7 over 2. So draw a right triangle. Maybe I'll put theta down here this time. Tangent is opposite over adjacent. So I'm going to put 7 opposite, 2 adjacent. This is not a triple that I know. So I'm going to say square root of 2 squared plus 7 squared. That would be C. That would be equal to C, right? So 4 plus 49 is 53. That does not simplify at all. Okay, so we have tangent. I always like to write these out in the same order, so I'm going to go sine first. Sine is 7 over radical 53. If you rationalize that, you get 7 radical 53 over 53. Remember, you do need to rationalize. Cosine theta is 2 over radical 53, which becomes 2 radical 53 over 53. We already have tangent. Cosecant theta is, remember, don't use your rationalized version. Go back here. This is why I like to bother writing it down so that it's easy to flip. Radical 53 over 7. Secant theta, same on this one. Go off of here. Flip that. Radical 53 over 2. And cotangent theta, reciprocal of 7 over 2 is 2 over 7. All right, now, the special right triangles. I know that you learned this in geometry. It's really, 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 really important. A lot of what we're doing is non-calculator, and if we're doing trig without a calculator, it means that we're basing things off of these 2 special right triangles. There are only a handful of angles that we can use that we know exact trig values for. So you have to memorize these. And we need to know them both in their degree form and their radian form. So let's start with degrees. Let's put 30 degrees up here, 60 degrees down here, drawing a 90-degree angle. What is 30 degrees in its radian form? It's pi over 6. 60 degrees is pi over 3. I remember that one, by the way, too, because it's kind of the opposite. Like 30 is over 6 and 60 is over 3. We don't have to mark in pi over 2. You can if you want to. And then what are the sides of the 30, 60, 90? So the shortest leg is opposite 30, and we give it a side length of 1. This is like the most reduced triangle we could have. The hypotenuse is double the short leg, so that's 2. And the leg opposite 60 degrees is the short leg times radical 3. So you need to know this version because, again, we're going to be using these to figure out what is the sine of 30, what's the cosine of 60, etc. The other really important triangle to know about is the 45, 45, 90. 45 degrees is pi over 4 in radians. And the side lengths here, because it's an isosceles triangle, the side lengths are 1, 1, and if you forget this one, do Pythagorean theorem, you get radical 2. So you have to memorize these to be able to do the rest of the semester, basically. Find the exact values of each trig expression. So this says tangent of 30 degrees. So we should be locating 30 degrees and finding the opposite over adjacent. Right? So opposite 30 degrees is 1. Adjacent to 30 degrees is radical 3. We're going to rationalize that. So the tangent of 30 degrees is radical 3 over 3. the sine of pi over 4. So remember, sine is opposite over hypotenuse. Pi over 4 is 45 degrees. It doesn't matter which angle you look at, they're the same. So opposite of the pi over 4 is 1. Hypotenuse is radical 2. So the sine of pi over 4 rationalized is radical 2 over 2. These are your speed quiz questions, by the way. The official speed quizzes, once we get past our common angles speed quiz, these are the speed quiz questions. Now, so far, I'm just giving you this small collection of angles. We will expand this, but this is what the speed quiz questions are like. So cosine is 60 degrees. So find 60 degrees. Go adjacent over hypotenuse. Cotangent. For the reciprocals, sometimes I have to flip them around or I show myself what it is. So instead of TOA, it's adjacent over opposite. Find pi over 6, that's 30 degrees. Adjacent is radical 3. Opposite is 1, so radical 3. Cotangent of pi over 6 is radical 3. The secant of pi over 3. So I really think about the cosine of pi over 3, and then I'm going to flip it. Or you could say, okay, it's the hypotenuse over the adjacent, however you want to do that. So let's find pi over 3. The hypotenuse is 2. The adjacent is 1. So our answer is 2. Cosine of pi over 3 was 1/2, and then you flip that and you also get 2. Cosecant of 45 degrees, that's hypotenuse over opposite. We actually did this one up here, right? 45 degrees is pi over 4. So the hypotenuse is radical 2. The opposite leg is 1. So the answer is radical 2. Cosine of pi over 3. I guess that's kind of just 9, but the reciprocal. But anyway, adjacent over hypotenuse. That's our final answer. Tangent of pi over 4. Opposite over adjacent. 1 over 1 is 1. All right. What about applications? If you're given a word problem, you need to draw a picture. If it's not given to you, you might still need to draw the given picture so that you can add things to it, label sides, label angles, etc. Based on what sides are given and where the angle is, you'll pick one of the correct trig functions, probably sine, cosine, or tangent, and then solve. All right. So a surveyor is standing 50 feet from the base of a large tree. The surveyor measures the angle of elevation to the top of the tree. I don't know why there's a person at the top of my tree, but whatever. Okay, so this is our tree. There's a person in a tree house or something. So we are 50 feet to the top from the base of a large tree. We're assuming the tree is straight up and down. Surveyor measures the angle of elevation to the top of the tree. So an angle of elevation is always from the horizontal. So this is 71.5 degrees. This is an angle of elevation. And something I want you to notice is that if there were a person in a little tree house or whatever up here, and they were looking down, that's called an angle of depression, because you're looking down. And that's measured from the horizontal. And think back to your alternate interior angle days of geometry. That's also 71.5 degrees. The most common mistake is people put an angle of depression in the triangle from the vertical, and it's not. It's always outside. Okay, how tall is the tree? We're trying to find, let's put an X right here, trying to find that height. So compared to 71.5, we're trying to find the side opposite, and we have a side adjacent. So which trig function uses those two items? Tangent. So we're going to set this up. Tangent of the angle is equal to opposite over adjacent. How do I solve this for x? Well, if it's x divided by 50, I multiply 50 over to this side. Now, the exact answer is 50 times tangent of 71.5 degrees feet, but I want to approximate this. So be careful of your calculator mode. If the angle in the trig function is in degrees, then your calculator needs to be in degree mode. So check your calculator, press mode, which is next to second, and if your calculator gets reset, it's going to reset to radian mode by default, so switch it over to degree for this problem. All right, and then that was 50 times, you just press tangent, tan, 71.5. And so this is how the calculator knows we mean 71.5 degrees. So how tall is the tree? Always round to three places. 149.434. Label that in feet because that was the dimension of the other leg. That's approximately equal to x. All right, next problem. No picture provided to start this one out. So at a distance 19 feet from its base, the angle of depression from the top of the flagpole to the point on the ground 19 feet away is 64.6 degrees. How tall is the flagpole? Anytime I'm given an angle of depression, I like to draw it as an angle of elevation because remember, they're going to always be equivalent. So here's my scenario. Flagpole, angle of depression to a spot that's 19 feet away. When we say angle of depression, we're always saying, imagine that you're sitting on top of this flagpole or whatever, looking straight out, and then you look down. That's 64.6. So that doesn't help me much because I'm outside of the triangle. I might as well put this down here as an angle of elevation, an alternate interior angle from your geometry days. These two angles are equal. So I'm trying to figure out how tall is the flagpole. So again, I'm going to use tangent because I have opposite and I have adjacent. So the tangent of 64.6 degrees is equal to x over 19. Multiply 19 over. So the exact answer is 19 times tangent of 64.6 degrees feet. But I want the approximate answer. And I get 40.014. Now we're going to label that with feet. It's approximately equal to x. We don't always use tangent. We often do because it's common to have a vertical and a horizontal measurement. But if I had something about the hypotenuse, that could cause me to use sine or cosine instead. All right, last thing. What if we need to solve for the angle? So how do we get rid of a trig function? Like I said before, it's an operation. It's sort of like when we had natural log of something, we had to base e both sides. So what do we do to undo a tangent or to get that out of there if the x is the angle itself? So we need an inverse function, and we will have more rules and more details about inverse trig functions later. But for now, just so that you're used to this notation, an inverse trig function, here's the notation. Inverse trig notation. If I want to undo cosine, because that's this example, instead, just like I had like f inverse of x, I would use cosine inverse of x. Okay, so what do I mean by that? Well, if cosine of x equals 3/5, then inverse cosine of cosine x has to equal inverse cosine of 3/5. Taking the inverse cosine of a cosine function cancels it out, and you get x equals whatever the inverse cosine of 3/5 is. Now we need our calculator to figure this one out. We type in second cosine to get the inverse function on there. So check this out. See how above each trig function it has something that looks like to the -1? That means inverse cosine, so second cosine. of 3/5. And because I'm in degree mode, my calculator will give me the angle in degrees. The answer is 53.130 degrees. Right? So that's our answer for our angle. And you can kind of check your work, which is cool. It won't be perfect, but you could say cosine of that angle should equal 3/5 or close to it. 3/5 as a decimal is 0.6, right? So it's a little off because this is rounded, but you get the idea. All right, so with all that said, we have this picture here. You are 200 yards from a river, so this must be you. Rather than walking directly to the river, you walk along a straight path to the river's edge. Find the acute angle theta, measured in degrees and in radians, between this path and the river's edge. So let's see. We have a right triangle here. 200 is the opposite leg. 400 is the hypotenuse, right? Because it's not one of the legs. It's not on the 90 degrees. And we're trying to find theta. So because we have opposite hypotenuse, we're going to set up sine theta equals 200 over 400. To get rid of the sine theta, I'm going to inverse sine both sides. 200 over 400 is just 1/2, right? So theta equals the inverse sine of 1/2. Find theta in degrees and radians. So second sine 1/2, 30 degrees. I could convert that to radians. It's pi over 6. Or I could change the mode in my calculator. Kind of depends on how the answer is supposed to be given. Inverse sine of 0.5 in radians is 0.524. That's what pi over 6 calculates out to, right? We could check that. Yeah. So either way for this one. I would convert if I would. I mean, it'll just depend if it's a calculator or non-calculator part. It won't matter. If you're allowed to use a calculator, you could use either answer here, I would think. All right, that's it for today. We're going to practice right triangle trig for the next day or two.